Welcome back to Lab to Lecture. This video to solve questions on topic 4 electrolysis for Cambridge IGCSE chemistry course. Let's get started. Question 1. Electrolysis is used to extract metals from metal compounds. Describe the electrolysis of molten lead bromide. So here we have molten electrolyte. In your answer, include a label diagram of the apparatus used, the names of the products formed at the positive and negative electrodes. So here we have molten lead bromide, which is PbBr2. Since it's molten, we don't have any hydrogen or hydroxide ions. So just here we have the positive lead ion and the negative bromide anion. Now the positive cation will get attracted to the cathode, and the negative anion will get attracted to the anode. So anion, anode, cation, cathode. And as we know that the anode is a positive electrode. So at the positive anode, we're going to have the anion, which is bromide, and then it will get discharged as bromine gas, Br2. At the negative electrode, which is the cathode, we're going to have the metal lead. Now for the label diagram, this is a quick diagram. Of course, in the exam, you should use a ruler and a pencil. And here we have the anode, which should be connected to the positive terminal of the battery. And there we have the cathode, which should be connected to the negative terminal of the battery. So anode is positive and cathode is negative. And in between, we have the electrolyte, which is a molten lead 2 bromide. Now the direction of flow of ions, the bromide ion will flow to the positive electrode, while lead ion, which is positive, will flow towards the negative electrode, and the direction of flow of electrons from anode to cathode. And once again, this is battery or power supply. The electrolysis of concentrated hydrochloric acid produces gases at each electrode. So hydrochloric acid is HCl, hydrogen and chloride, and it's concentrated. It means in presence of hydrogen ion and hydroxide ion of water, but the overall solution is concentrated. So as you may remember, if the solution is concentrated, then the halogen is going to discharge. So chloride ion is going to discharge at the anode, while the hydrogen ion is going to discharge at the cathode. So at the positive anode, we're going to have the anion, and the anion is chloride, and it's going to turn into chlorine. So here we have chlorine. And at the negative cathode, we have the cation. Hydrogen will turn into hydrogen gas. Once again, he's asking for a diagram. In case you have gases released, you may apply inverted test tube to collect these gases. So we may have exactly the same layout, but now I'm just going to apply inverted test tubes. It's not a must, but we prefer to use test tubes to collect gases. So here we have the anode, which is the positive electrode because it's connected to the positive terminal of the battery. In that scenario, I'm going to put the battery here down below. So here we have the battery, and this is the positive of the battery. Here you have the negative of the battery, and this is the cathode because it's connected to the negative of the battery. At the anode, we're going to collect the chlorine gas. So here we have chlorine gas, and there we are going to, at the cathode, you're going to collect the hydrogen gas. And don't forget to label the battery. And also here we have, in between electrodes, we have the electrolyte. In that situation, the electrolyte is concentrated hydrochloric acid. So once again, don't forget to label the anode, cathode, electrolyte. Those are the main components, and also electrolysis happens in presence of the power source or battery. And if it's possible to label the gases that are produced at the anode and cathode, that will be much better. Don't forget, your drawing has to be in pencil and it has to be neat and clear. You have to use ruler in order to make the lines straight as possible. Electrolysis is carried out on aluminium oxide dissolved in molten cryolite. First, give two reasons why electrolysis. First, give two reasons why the electrolysis is carried out on aluminium oxide dissolved in molten cryolite instead of electrolyzing molten aluminium oxide only. In other words, he's asking for the role of cryolite. Two main reasons. The first one, to lower the operating or working temperature. Secondly, to improve conductivity of the electrolyte. Next, B. Write the ionic half equation for the reaction occurring at the negative electrode. So at the negative electrode, which is cathode, you should look for the cation, and the cation, in case we have aluminium oxide, the cation is aluminium, so we have to write an equation for aluminium. So we have aluminium 3 positive, it takes 3 electrons and it gives the aluminium element or metal. The positive electrodes are made of carbon. Explain why the positive carbon electrodes, sometimes call them graphite, are replaced regularly. We replace the carbon or graphite in case of the extraction of aluminium because carbon anode or electrode reacts with oxygen to form or produce carbon dioxide. The next question, a metal spoon is electroplating with copper. It means we are going to deposit copper on the surface of a metal spoon. State what is used as the positive electrode or anode. Remember that anode always dissolves, so we should have copper as anode. While the object to be plated, it has to be connected as a cathode. In that example, it's going to be the spoon that's going to be plated. And the electrolyte has to be aqueous solution of a salt that contains the positive cation of the depositing metal. So in that situation, it's going to be aqueous solution of copper salt. Next, electricity can be used to break down aqueous or molten ionic compounds. Name the process which uses electricity to break down aqueous or molten ionic compounds. So that's electrolysis. And next, explain why ionic compound needs to be aqueous or molten. Simply, we need the ions that are free to move. We call them mobile ions. Mobile ions. So that's the reason why we can't use solid ionic compounds in electrolysis. Next, brine is concentrated aqueous sodium chloride. So here we have sodium chloride solution, which is concentrated, sodium positive, chloride negative, in presence of the hydrogen ion and hydroxide ion of water. Since it's concentrated, we know that the chloride ion is going to discharge in preference of the hydroxide ion. And between the two cations, hydrogen is going to discharge because reactive metals never discharge in aqueous solutions. So name 3 substances which are manufactured by passing electricity through brine. So firstly, you can produce chlorine at the anode, and we can produce hydrogen gas at the cathode, and what remains after the discharge of these ions is going to be sodium hydroxide. So we can produce hydrogen, gas, we can produce chlorine gas, and also we can produce sodium hydroxide, because what's left behind after the discharge of these ions is going to be sodium hydroxide. Next, name a different substance formed when molten. So now we're going to change it from being aqueous into molten. Molten means we don't have hydrogen and hydroxide ions of water. So in case you have a molten electrolyte, then we're not going to discharge hydrogen, and the ion that's going to be discharged at the cathode is going to be the sodium. So now sodium will form at the cathode. This question is about electrolysis. Concentrated hydrochloric acid is electrolyzed using the apparatus shown. Chloride ions are discharged at the anode. Complete the ionic half equation of this reaction. So the chloride ions, chlorine exists as diatomic, so it has to be chlorine gas as a diatomic. That's why we need to use 2 ions of the chloride, and of course it's going to release 2 electrons. State whether oxidation or reduction takes place and explain your answer. We haven't discussed redox reaction so far, but the reaction that involves loss of electrons, when electrons are in the product side, that is an oxidation. So that's an oxidation because it involves loss of electrons. And you can just remember it with oil rig. Oil, O stands for oxidation, I is, and L loss. So oxidation is loss of electrons, reduction is gain of electrons. Since here we have a loss of electrons, in the product side, that's why it's an oxidation process. Describe what's seen. Okay, so here he is asking about an observation, and this is very important. You have to pay attention whether he's asking for observation, it means what is seen, or product, so what is produced. What is produced, it means he needs the name of the substance, but observation, it means you have to mention whether you have effervescence, you have a color change, or you have fumes, like green gas, like brown fumes, but the identity of the substance is not important. So now he's asking at the cathode. Okay, cathode is negative, and for the negative electrode, the positive cation is going to discharge. Since here we have the electrolyte is hydrochloric acid, so we have hydrogen and we have chloride. So at the cathode, the positive cation of hydrogen is going to discharge. So now we're going to describe the discharge of hydrogen ion as hydrogen gas. And of course, hydrogen gas is going to discharge with effervescence of the hydrogen gas, which is a colorless gas. Remember, the identity of the gas is not important. So it's not important to mention whether it's a hydrogen or any other gas, just the color and the fizzing or effervescence. Next, this question is about electrolysis. The table gives information about the electrolysis of 2 electrolytes. Carbon or graphite electrodes are used in each experiment, which are inert. Complete the table to show the observations and products. So he needs what you're going to see, and he needs the identity of the produced substance. So at the anode and at the cathode, in case you have aqueous, copper 2 sulfate. So once again, this is copper 2 sulfate CuSO4. Copper is a 2 positive, sulfate is 2 negative ion, and it's aqueous. It means we have hydrogen and we have hydroxide ions. At the anode, hydroxide is going to get discharged in preference to the sulfate, and at the cathode, copper is going to get discharged in preference of the hydrogen. So that's cathode discharge, and that's anode discharge because it's an anion. So he's asking for the observation at the anode. Observation is effervescence of oxygen gas. That's why we have colorless bubbles, because oxygen is colorless, and the name of the product, oxygen gas. While at the cathode, we have the deposition of the copper. So we have brown or reddish brown deposit from copper, and the name of the product is copper. Now, if we have concentrated sodium bromide, so sodium bromide, NaBr, Na is positive, Br is negative. Once again, it's aqueous. It means we have hydrogen and hydroxide. Now, in case we have a concentrated solution, now the halogen or the halide ion is going to discharge because it's concentrated, and that's going to get discharged at the anode because it's an anion. While at the cathode, of course, hydrogen is going to get discharged because, any reactive metal is not going to get discharged in aqueous solutions. So hydrogen is going to get discharged at the cathode because it's a cation. So once again, at the anode, so we have bromine gas get discharged, and it discharges in the form of a brown gas or brown fumes. So here we have brown fumes. And hydrogen, as we said before, is going to be at the cathode as a colorless bubbles because hydrogen is colorless. The next question, B. Hydrogen is produced at the negative electrode cathode during the electrolysis of concentrated aqueous sodium bromide. Write the ionic half equation for this reaction. So hydrogen ion, H positive, it's going to discharge by the removal of that positive charge. So we need an electron to remove the positive. But since hydrogen get discharged in the form of a diatomic molecule, we need to use 2 of the hydrogen ions and 2 of the electrons. So this is the half equation for the discharge of the hydrogen gas. Next, state 2 reasons why carbon or graphite is suitable to use as an electrode. Firstly, it's an inert. Inert means it's not going to react, so no reaction will take place with the electrolyte. That's number 1. Number 2, it's a good conductor. Remember, in topic 2, we discussed how graphite is a good conductor of electricity. So it's a good conductor of electricity. So that's 2 marks. Next question, question D. Name the particle responsible for the conduction of electricity in the metal wires used in a circuit. So in a metal wire, remember the charge carriers are electrons. In solutions, charge carriers are ions, but in solid metals, they are electrons. Next question. This question is about electrolysis. State the meaning of the term electrolyte. Electrolyte is defined as a substance or ionic compound, molten or aqueous, that undergoes electrolysis. So that's an electrolyte. Next, give the name of the process that's used. This is like an integrated question, and the point that we are interested in is C, which is to produce bromine from molten lead bromide. That's an electrolysis. So the process electrolysis is used to produce bromine from molten lead to bromide. Let's just answer the rest of the parts, but if you can't figure them out, don't panic. Later on, we're going to discuss them. So A, he is asking about the name of the process to produce ammonia from nitrogen. That's called Haber process. To separate nitrogen from liquid air, that's fractional distillation. Fractional distillation. To separate an undissolved solid from an aqueous solution, that's filtration. To produce amino acids from proteins, that process is opposite to polymerizations to produce proteins, but now we're going the opposite way, so that's hydrolysis. Hydrolysis. So from amino acids to proteins, the process is condensation or polymerization. But from proteins to amino acids, the process is hydrolysis. Next, to separate a mixture of amino acids, that's chromatography. Chromatography. A student carries out an electrolysis experiment using the apparatus shown. The student uses dilute aqueous sodium chloride. So we have NaCl, sodium chloride. Na is positive, chloride is negative, and it's aqueous. It means we have hydrogen and hydroxide, and it's dilute. It means hydroxide is going to discharge in preference to the chloride. So that's going to discharge since it's an anion at the anode. And of course, among the two positive cations, hydrogen is going to get discharged because, hydrogen is less reactive than sodium. Any reactive metal, it's not going to discharge. So it's not going to discharge. So that's why hydrogen at the cathode, because it's a cation. Hydroxide ions are discharged at the anode, and that agrees with what we just said here. So A, complete the ionic half equation for this reaction. I really recommend if you know the equation for the discharge of hydroxide, because that's very common in the exam and that saves a great deal of time for you. So we know that hydroxide produces oxygen gas and it forms two water molecules. So we need 4 hydroxide ions in order for the equation to be balanced. Next question. Explain how the ionic half equation shows the hydroxide ions are being oxidized. So once again, this is an oxidation reduction reaction. So any oxidation, remember, oil rig oxidation is loss of electrons. So you just say that hydroxide ions or OH negative ions lose electrons. And that will come later when we discuss redox reactions. Next, a student carries out an electrolysis experiment using the apparatus shown. The student uses dilute aqueous sodium chloride, so exactly like we did before here. Dilute aqueous sodium chloride, exact same situation. So describe what the student observes. So he needs observation. He doesn't need any name of the product. So he needs observation like bubbles, like color of the gas. So what we're going to observe at the cathode, remember at the cathode, the cation is going to discharge, and the cation that's going to discharge is hydrogen as a hydrogen gas. So we have effervescence of hydrogen gas or bubbles of hydrogen gas. So effervescence of colorless gas. You don't need to mention the name of the gas. So effervescence of a colorless gas. A colorless gas. Next, write the ionic half equation for the reaction at the cathode. So remember, at the cathode we have the cation hydrogen, 2 of it. It will gain 2 electrons and it will form hydrogen gas, H2. Any hydrogen is a diatomic molecule, so that's why we use 2 cations of hydrogen. Next, the student repeats the experiment using concentrated aqueous sodium chloride. So instead of having dilute, concentrated. And you know the difference between them. In case it's concentrated, now chlorine will get discharged in preference of the hydroxide ion. So now chlorine will get discharged. And you know, in concentrated, the difference is chloride ion is going to get discharged in preference of the hydroxide ion because it's concentrated now. So chloride gets discharged into chlorine. So at the anode, we have chlorine gas instead of the oxygen gas, while at the cathode, always the cation hydrogen is never there because sodium cannot get discharged in aqueous solutions. So at the cathode, still we have hydrogen gas. Next, the student added litmus solution to the solution after the electrolysis of the concentrated aqueous sodium chloride. So remember, we're now working with the concentrated. Once again, in concentrated, we're going to get chloride discharged, and we're going to get hydrogen discharged, and what remains is sodium, cation, and hydroxide. So we have sodium and hydroxide. That's why the remaining electrolyte or solution is sodium hydroxide. So sodium hydroxide means we have an alkali, and alkali turns litmus solution into blue. So the color of the solution is blue, and the reason, because sodium hydroxide remains and we know that sodium hydroxide is an alkali that will turn the litmus solution into blue. Next, a student carries out an electrolysis experiment using the apparatus shown. The student uses dilute aqueous sodium chloride. So back again, we have a dilute situation. Remember, in dilute situation, hydroxide is going to get discharged in preference to the halogen or halide. Carbon electrodes are used because they are inert. State another element that can be used instead of carbon. So what else can be used along with carbon or graphite? We have platinum. Platinum is also an inert electrode. Next, molten sodium fluoride, NaF, undergoes electrolysis. Name the products formed at the positive electrode anode and negative electrode cathode when molten sodium fluoride undergoes electrolysis. So here we have a molten situation, and that's the easiest one because in molten situation, cation to the cathode, anion to the anode. So at the anode, we have the anion, which is fluoride, and then it gets discharged into fluorine. And the cathode, we have sodium. Next, molten sodium fluoride undergoes electrolysis. Write the ionic half equation for the reaction at the negative electrode cathode. So cathode, we need the cation, which is sodium. So we need Na positive, and it takes an electron to give Na. Next, concentrated aqueous potassium chloride. So we have potassium chloride concentrated, so K positive, Cl negative in presence of the hydrogen and hydroxide. Remember, it's concentrated means the halide ion is going to get discharged at the anode, and cathode will have the hydrogen. Name the product formed at the positive anode. So at the anode, we have chlorine. Concentrated aqueous potassium chloride undergoes electrolysis. Name the potassium compound that remains in the solution after electrolysis. So once again, we have potassium chloride concentrated. What remains after the discharge of chloride and hydrogen is potassium hydroxide. Since here he is asking you to write the name, no need to write the formula of the compound. So the remaining compound is potassium hydroxide. Next, name the products formed at the positive electrode anode and negative electrode cathode with molten potassium chloride. Now we have a molten situation. Molten, it means you don't have any hydrogen or hydroxide. So at the anode, the anion, which is the chloride, and it forms chlorine gas. At the cathode, the cation, which is potassium. Aqueous sodium fluoride, NaF, undergoes electrolysis. Name the products formed at the positive electrode anode and negative electrode cathode when dilute aqueous sodium fluoride. So it's dilute and aqueous. So sodium, Na, fluoride, F, positive, negative, hydrogen, and hydroxide. Now, since it's a dilute solution, the hydroxide is going to get discharged at the anode. And of course, here hydrogen is going to get discharged at the cathode. So at the anode, we have oxygen from hydroxide, and at the cathode, we have hydrogen gas is going to get formed. A student carries out an electrolysis experiment using the apparatus shown. The student uses dilute aqueous sodium chloride. So once again, sodium chloride, positive, negative in presence of hydrogen and hydroxide. Since it's dilute, hydroxide is going to get discharged at the anode, and of course hydrogen is going to get discharged at the cathode. And he's asking you to state the name given to any solution which undergoes electrolysis. So he gave you just a question, and he asked you like a generic question. State the name given to any solution that undergoes electrolysis. That's a definition of an electrolyte. Dilute sulfuric acid is electrolyzed using the apparatus shown in the diagram. State what's meant by the term electrolysis. So that's a common definition in the exam, so you have to learn the definition of electrolysis. Electrolysis is defined as the decomposition of an ionic compound when molten or in aqueous solution by the passage of an electric current. Plain why inert electrodes are used, so to confirm that no reaction takes place, or in other words, they do not react. Such an easy question. Next, name the products formed at each electrode. So let's get back to the example here. So here we have dilute sulfuric acid. So we know sulfuric acid is H2SO4. So we have the hydrogen and sulfate ions. It's dilute. It means in presence of hydrogen ion from the water and hydroxide. Hydroxide is going to get discharged in preference to the sulfate, and hydrogen exists here in either situation. So we have hydrogen and hydroxide. In other words, you have simply the electrolysis of water. So at the negative cathode, we have the cation, which is hydrogen, and that forms hydrogen gas. At the anode, we have the anion, which is the hydroxide, and that gives you the oxygen gas. Write an ionic half equation for the reaction at the negative electrode. So he's asking for an ionic equation at the anode. So we're going to pick the anion. So we have the anion. Write an ionic half equation for the reaction at the negative electrode. Negative electrode means cathode. So we're going to pick the cation, and the cation here is hydrogen. Once again, two of it. They take 2 electrons and give hydrogen gas. Next. Sodium is extracted from sodium chloride by electrolysis. State the meaning of the term electrolysis. We just mentioned it before. It's decomposition of an ionic compound in molten or in aqueous solution by passage of an electric current. State what must be done to sodium chloride before it can be electrolyzed to produce sodium. Once again, it has to be in the form of a molten electrolyte, so that's why we have to heat it. So it has to be heated till it melts. So it has to be in the molten state for the ions to be free or mobile. Next, write an ionic half equation for the change that occurs at the cathode during this electrolysis. So cathode, we have to pick the cation, which is sodium. So sodium positive will take an electron and it gives sodium metal. Next, sodium chloride does not conduct electricity when solid, but does conduct electricity when molten. Explain why in terms of structure and bonding. So that's pretty like a topic 2 question. So as we know that ions are fixed or not able to move in the giant ionic lattice, while in the molten state, ions are free to move. In other words, they are said to be mobile. Next, name the product formed at the positive electrode or anode when electricity is passed through molten sodium chloride. So at the positive anode, you have to pick the anion, and the anion is chloride, so chlorine. Next, state the type of change that occurs at the positive electrode in B. So in the previous part here, at the positive electrode, he wants the type of change. So in general, at any anode, the change is always oxidation. And remember, oxidation, oil means loss of electrons. So the explanation, because electrons are lost, or there is loss of electrons. So electrons are lost. Next, describe what else can be done to sodium chloride to allow it to conduct electricity. So in the previous situation, we discussed having it in the molten state. So also we can get it dissolved in water. In other words, to have it in the form of aqueous solution. Next, aluminum is used in overhead electricity cables. Give 2 properties of aluminum that make it suitable for use in overhead electricity cable. You may just mention any generic property of metals, like they are ductile and malleable, and it conducts electricity, or you may mention that it has low density. Next, magnesium fluoride does not conduct electricity when it's solid. What can be done to solid magnesium fluoride to make it conduct electricity? In your answer, Explain why magnesium fluoride conducts electricity when this change is made. So once again, we need the electrolyte to be in the form of molten or in aqueous solution. So the change is when molten or in aqueous solution. Aqueous solution. It means when you dissolve it in water. And the reason why, because this question is 2 marks, because ions are going to be free to move. In other words, they are going to be mobile. Next, electrolysis of concentrated aqueous sodium chloride using inert electrodes forms chlorine. What's meant by the term electrolysis? Name a substance that can be used as the inert electrodes, carbon in the form of graphite or platinum. So we can say carbon in the form of graphite or platinum. Write an ionic half equation for the formation of hydrogen during this electrolysis. So once again, we have 2H positive plus 2 electrons give hydrogen gas. Give the formulae of the 4 ions present in concentrated aqueous sodium chloride. So we have 4 ions. We have sodium cation and we have chloride ion from sodium chloride. We have a hydrogen ion and hydroxide ion from water. Explain how sodium hydroxide is formed during this electrolysis. So once again, we have concentrated aqueous sodium chloride. So this is sodium chloride, positive, negative in presence of hydrogen and hydroxide. Remember, when it's concentrated, chloride ions are going to get discharged at the anode and hydrogen is going to get discharged at the cathode. So what's left behind, what remains is sodium and hydroxide. So you may say, because hydrogen ions will discharge or get removed at the cathode, chloride ions will discharge or get removed at the anode, while sodium cations and hydroxide ions will remain in the solution and they will form sodium hydroxide. That question is 2 marks. So 1 mark for telling what's going to get discharged. Hydrogen and chloride ions are going to get discharged, and what are going to stay or remain in the solution. So sodium and hydroxide are going to remain in the solution. The last question here, once again, extraction of aluminium. So aluminium is extracted from its ore. The ore is converted into pure aluminium oxide, which then undergoes electrolysis as shown. Name an ore of aluminium. So the name of the ore is bauxite. What's meant by the term electrolysis? Once again, the decomposition of an ionic compound in the form of molten or in aqueous solution by passage of an electric current. Aluminium oxide has a melting point of about 2000 degrees Celsius, but the electrolysis process operates at about 900 degrees Celsius. Name the compound added to aluminium oxide to reduce the operating temperature. Remember, that's cryolite. Also remember, cryolite improves the conductivity of the electrolyte. Suggest one benefit to the environment of reducing the operating temperature. Less energy is needed. That's why less fossil fuel is needed and eventually less carbon dioxide emissions. Write the ionic half equation for the reaction taking place at cathode and anode. So remember the ore aluminium oxide, so it's Al2O3, so we have aluminium cation and oxide ion. So the cation at the cathode, so that's aluminium, is 3 positive, so it needs 3 electrons and it gives aluminium Al without a charge. At the anode, the anion is oxide ion, so it gets discharged into oxygen, but oxygen is diatomic, that's why we have to use 2 of the ions, and that's why we're going to release 4 electrons, because each ion has 2 negative charges, so 2 of it will have 4 negative charges, and that's why it's going to release 4 electrons. Next, explain why the anodes need frequent replacement. Remember, we need to replace carbon because carbon reacts with oxygen and it produces carbon dioxide, so it burns away with time, so we need to replace it. So the answer is carbon reacts with oxygen to form carbon dioxide. Another last question. Magnesium cannot be produced by electrolysis of aqueous magnesium chloride using inert electrode. Name the product formed at the negative electrode cathode during the electrolysis of aqueous magnesium chloride. So once again, magnesium chloride, MgCl2. Magnesium is positive, it's positive 2. Chloride is negative. It's aqueous, it means we have hydrogen and hydroxide. At the cathode, the cation that's going to get discharged is the hydrogen, because hydrogen is less reactive than magnesium. So the product is going to be hydrogen at the cathode. And suggest how magnesium can be produced from magnesium chloride by electrolysis. So in aqueous solution, magnesium will not get discharged because it's more reactive. So the only way that we can get magnesium discharged when it's molten. So we need to have it in the molten form. So heat until magnesium chloride is molten and electrolyze. That's it for today. If you have any question, just leave it in the comment box below. Also, if you need the file, the whole file, just send me an email and I'm going to forward it to you with the answer key. So see you next time.